Hey guys, tonight we're diving into something that should have changed the world, not through conquest, not through prophecy, but through ideas that arrived about 1,000 years too early. We're talking about a civilization so advanced, so precisely ahead of its time, that history basically had to look away. Before you get comfortable, hit like and subscribe, but only if this is genuinely your kind of thing. A huge thank you to Jaden Parker from California for planting this seed. Suggestions like yours are quietly steering where this channel goes, and I mean that. Drop a comment with where you're listening from tonight, and what time it is wherever you are. Now dim the lights, find a comfortable spot, maybe pull a fan on low, and go ahead and set down whatever textbook told you Western Europe invented progress, because after tonight, ahead of its time is going to sound a lot more like an obituary. Let's pause for a second. Have you ever built something extraordinary, only to watch the world shrug? What if the problem was never the idea, but the century it landed in? And how many times has history already forgotten someone who got there first? Imagine you are standing in the middle of a vast desert, miles away from the nearest town, and somehow, without a single wire or tower in sight, a message finds you. Not through a phone, not through radio waves bouncing off satellites, but through the land itself, through stone and water and the quiet hum of the earth beneath your feet. It sounds like something out of a dream, does it not? But here is the extraordinary thing. Ancient civilizations may have done exactly that. Across the world, from the highlands of Peru to the plains of ancient Mesopotamia, researchers have discovered networks of raised roads, stone pathways, and elevated platforms that seem, on the surface, to be simple trade routes. But look closer, and something remarkable begins to emerge. These pathways were not just roads. Many of them were aligned with extraordinary precision to mountain peaks, river bends, and celestial landmarks that could only be confirmed from high altitude or from careful astronomical observation. The Inca, for instance, built a road system spanning over 25,000 miles across some of the most brutal terrain on Earth. But beyond transporting goods, these roads functioned as a communication network. Relay runners called chasquis could carry messages from one end of the empire to the other in just a matter of days, faster than many modern postal systems of the 18th century. And here is where it gets even more fascinating. Some archaeologists now believe that the positioning of these relay stations was not random. They were placed in alignment with acoustic and visual sightlines, essentially creating a system where both sound and light could carry signals across enormous distances. In other words, the land was wired, not with copper or fibre, but with knowledge, geography, and human ingenuity. It makes you wonder, does it not, when we congratulate ourselves for connecting the world? Perhaps the world was already connected long before we arrived. Picture yourself as a farmer living 3,000 years ago. You have no calendar on your wall, no clock on your wrist, no weather app on your phone, and yet you need to know exactly when to plant your crops, when the rains will come, and when the nights will grow long again. Your survival depends on it. So what do you build? You build a machine, not out of circuits and silicon, but out of stone. This is not a metaphor. The ancient world is filled with stone structures that functioned with breathtaking accuracy as calculating devices. The most famous of these is Stonehenge, located on the Salisbury Plain in southern England. For centuries, people assumed it was simply a ceremonial site, a place of worship or ritual, but modern analysis tells a far more compelling story. Stonehenge, as it turns out, is a remarkably precise solar and lunar calculator. The positions of its massive stones track the solstices, the equinoxes, and even the cycles of lunar eclipses over an 18.6-year period, a cycle that modern astronomers call the Metonic cycle. The people who built Stonehenge did not just observe the sky, they encoded it permanently into stone. And Stonehenge is far from alone. In Nabta Playa, Egypt, an even older stone circle, dating back to approximately 7,000 years ago, was aligned with the summer solstice and certain prominent stars. In Chichen Itza, Mexico, the Pyramid of El Castillo creates a shadow serpent precisely on the spring equinox, a visual display of mathematical precision that would challenge even modern architects. These were not decorative monuments. They were instruments, tools for tracking time, predicting seasons, and managing entire civilizations. The aha moment here is quiet but profound. We did not invent computing. We reinvented it. Ancient hands simply used heavier keyboards. What if you were placed in a museum thousands of years from now, and the curator pointed to a photograph of a jumbo jet and said, "We are not sure what this was used for." Perhaps it was symbolic. You would want to laugh or cry because you know exactly what it was. Now consider how that might feel from the other side of history. In the Cairo Museum in Egypt, there sits a small carved object discovered in a tomb near Saqqara in 1898. For decades it was labelled simply as a bird figurehead and filed away in a box. Then, in 1969, Dr. Khalil Messiah, an Egyptian archaeologist, took another look. What he saw stopped him cold. The object was not shaped like any bird in nature. It had a flat, horizontal tail which no bird possesses. Its wings were angled and shaped with aerodynamic lift properties. When a replica was built and tested in a wind tunnel, it glided with remarkable stability. It looked unmistakably like a model of a flying craft. Was it a toy? A votive offering? A scale model of something larger? We may never know for certain. But it is not alone. In Colombia and other parts of South America, small golden figurines have been discovered, also dismissed as zoomorphic art, which, when tested in wind tunnels, demonstrated functional aerodynamic properties. Modern engineers have built scaled-up replicas of these figures and successfully flown them. Now, this does not mean ancient people were flying jet aircraft, but it does suggest something significant, that these civilizations were thinking about flight, studying it, modelling it, in ways that went far beyond simple admiration of birds. The sky was not just something they looked up at, it was something they reached for. Think about the last time you walked into a building and felt something shift. Maybe it was a cathedral, or an old library, or even a quiet forest clearing. Something in the air changed. Your heartbeat slowed. Your thoughts grew wider, somehow. You probably called it atmosphere. But what if it was physics? Ancient temple builders around the world seem to have understood something that modern science is only now beginning to confirm, that certain geometries and materials interact with sound and energy in ways that profoundly affect human consciousness. The ancient temples of Malta, known as the Hypogeum, are among the most extraordinary examples. Carved entirely into limestone rock approximately 5,000 years ago, the Hypogeum contains chambers with remarkable acoustic properties. Specific chambers resonate at a frequency of approximately 110 Hz, a frequency that researchers at Princeton University and the European College of Neuropsychopharmacology have found causes shifts in brain activity, specifically suppressing the language center of the brain and amplifying the spatial, imagery-oriented side. In other words, the ancient builders of Malta may have designed their sacred spaces to literally alter the state of mind of anyone who entered and chanted or spoke within them. This is not mysticism. This is architecture and acoustics working at a level of sophistication that most modern buildings do not even attempt. Similar findings have emerged from studies of Stonehenge, the Newgrange Passage tomb in Ireland, and numerous temples across India and Southeast Asia. These were not just places to honour gods, they were engineered environments designed to bring the human mind into a specific state. And perhaps that was the point all along, that the sacred and the scientific were never two separate things, that to touch the divine, ancient builders simply understood how to tune the room. Close your eyes for a moment and imagine walking across a field one that stretches for miles, and realizing that the entire landscape beneath your feet is a face. A massive, sleeping face carved into the earth itself, so large it can only be seen from the sky. Now open your eyes, because this is not imagination. This is the Nazca Lines of Peru. Etched into the Nazca Plateau in southern Peru, the Nazca Lines are a collection of enormous geoglyphs created approximately 2,000 years ago by the Nazca civilization. These include geometric shapes, straight lines running for miles without deviation, and giant figures of animals and humans, some stretching up to 300 meters in length. A hummingbird, a condor, a spider, a monkey with a spiraling tail. The precision of these lines is staggering. In a desert landscape that seems to shift and blur under the brutal sun, the Nazca people created figures that are geometrically nearly perfect, and they did so without satellite imagery, without aerial photography, without any tool we have yet identified. One theory suggests they used a system of scaled grids, essentially graph paper translated onto the land using simple wooden stakes and rope. Others have proposed more elaborate explanations involving atmospheric balloons or elevated viewing platforms. None of these theories has been definitively proven. What we do know is this: the Nazca did not build these figures for themselves. The figures are invisible from the ground. They were built to be seen from somewhere above. Whether that audience was divine, astronomical, or something else entirely, the intent is unmistakable. Someone was looking down. And the Nazca knew it. Suppose you found yourself in ancient Greece, standing on a hillside at dusk, watching a distant mountain. Suddenly, a light appears. Then another, miles away. Then another after that, each one answering the previous in a chain stretching across hundreds of miles of rugged terrain. No wires, no electricity, just fire and knowledge. This was the ancient Greek optical telegraph, a system so efficient it could transmit specific coded messages across vast distances in minutes. But this is only the beginning of the story. The ancient world developed numerous methods for transmitting information wirelessly, using nothing more than light, sound, and clever design. The Romans used polished bronze shields to signal across valleys. Armies across Asia used smoke signals that carried not just simple warnings, but complex encoded instructions. In Africa, drum systems developed by various cultures could transmit messages at speeds and distances that astonished European explorers in the 19th century. But perhaps the most sophisticated example comes from ancient China, where the signal beacon towers of the Great Wall formed a communication network that could relay a message from the western frontier to the capital in just a few hours. Each tower was positioned within visible range of the next, and a standardized system of fires and smoke patterns allowed for nuanced communication far beyond simple alerts. Here is the quiet genius of it all. These ancient systems did not just transmit information. They were designed with redundancy, with backup towers, with alternative signal routes, in ways that mirror how modern digital networks are designed to reroute data around failures. The principle of resilient, wireless communication is not new. It is ancient. The medium has changed. The wisdom behind it never did. Let us try a small thought experiment. Imagine you open an antique box and inside find a small clay jar, a copper cylinder, an iron rod, and traces of an acidic substance. Separately, they seem unremarkable, but arrange them correctly, add the acid, and something almost magical happens. You get electricity. This is not a thought experiment. This is the Baghdad battery, also known as the Parthian battery, discovered in the village of Kuyut Rabuar near Baghdad in 1938. The object dates to somewhere between 200 and 250 Common Era, belonging to the Parthian or Sassanid period. When archaeologist Wilhelm Koenig examined it, he was struck by a troubling thought. This looked like a galvanic cell. When replicas were built using grape juice or vinegar as an electrolyte, The device produced a small but measurable electrical current between 1 and 2 volts. Now, the mystery is not just that the object exists. The mystery is what it was used for. Some researchers suggest electroplating, and there is evidence of gold-plated silver objects in the ancient Near East that may have been produced this way. Others propose medical applications, using mild electrical current for pain relief, a practice not unlike modern transcutaneous electrical nerve stimulation, commonly known as TENS therapy. The uncomfortable truth is, we do not know for certain. The Baghdad battery sits in the Iraqi museum, quietly daring us to explain it. But here is what it tells us. Regardless of its purpose, the generation of electrical current from chemical reactions is not a modern discovery. Someone, more than 1700 years ago, held a small clay jar and caused electricity to flow. Not by accident, by design. Have you ever been in a quiet room and felt a low-frequency hum that seemed to pass straight through you, as if the air itself was pressing on your chest? It is an unsettling feeling. It can cause anxiety, disorientation, a sudden and irrational desire to leave. You have just experienced, in a mild way, the principle behind infrasound. Infrasound refers to sound waves at frequencies below 20 Hz, below the threshold of human hearing. You cannot hear it, but your body absolutely feels it. At specific frequencies, infrasound can cause a range of effects including fear, disorientation, visual disturbances, and a profound sense of unease. At higher intensities, it can disrupt balance, impair judgment, and even cause physical pain. Modern militaries have explored infrasound as a non-lethal weapon, but the extraordinary suggestion, supported by a growing body of archaeological research, is that ancient builders may have already known this and used it deliberately. Researcher Vic Tandy, while working in a laboratory in Coventry, England in 1998, discovered that a standing wave of approximately 18.98 Hz was causing his colleagues to feel anxious, see shadowy figures, and feel what the source was a fan. But the principle carried his imagination to ancient structures. Subsequent acoustic studies of sites including the Halsaflieni Hypogeum in Malta, Newgrange in Ireland, and several Egyptian temples have revealed that these spaces, by their geometry and material, naturally resonate at frequencies in the infrasound range. Were these effects intentional? Were ancient priests and architects engineering spaces to induce specific psychological states in those who entered, creating an experience of the divine through carefully designed sound? The silence around this question is, in itself, deeply loud. Imagine holding a letter that looks completely blank. No words, no markings, nothing to suggest it carries any meaning at all. But hold it near a flame, and words begin to appear, rising out of the white paper like ghosts awakening from sleep. This is not a spy novel. This is ancient steganography, the art of hiding messages in plain sight, and it is far older and far more sophisticated than most people realize. The earliest documented use of invisible ink comes from ancient Greece. The historian Pliny the Elder documented the use of the milk of the tithymulus plant as a writing fluid that became visible when heated. Ovid, the Roman poet, suggested using fresh milk, which darkens when exposed to heat because of the Maillard reaction, the same chemical process that browns your toast. But ancient civilizations went far beyond simple heat-reactive inks. The Greeks and Romans also documented the use of alum solutions, which become visible when washed with a tannin solution. Chinese imperial courts reportedly used rice water, which becomes transparent when dried but glows under ultraviolet light, a property not explained until modern chemistry. And then there is the extraordinary case of Hystaius of Miletus, recorded by Herodotus, who shaved the head of a trusted slave, tattooed a secret message onto his scalp, waited for the hair to regrow, and then sent the man on his way. The message was invisible until the recipient shaved the man's head again. That is not just clever. That is a system of invisible communication so elegant it remained unbreakable simply because no one would think to look for it. Ancient secrecy was not crude. In many ways it was extraordinary. Consider what it would feel like to stand on a rooftop in ancient Alexandria watching ships disappear over the horizon, knowing that miles away another pair of eyes was watching for your signal. And somehow, across that impossible distance, you could speak. Not with words, but with light. The ancient world developed systems of long-distance optical communication that were, in some cases, astonishingly precise. But beyond the fire signals and mirror reflections we have already touched on, there exists a category of ancient communication that goes even deeper into mystery. In the ancient Indus Valley civilization, which flourished between roughly 3000 and 1500 before the Common Era, researchers have discovered a system of writing that remains undeciphered to this day. The Indus script appears on thousands of small seals, tablets and tools found across a civilization that stretched from modern Pakistan into northwestern India. What makes the Indus script uniquely puzzling is not just its silence, but its consistency. The same symbols appear across an area of about 1 million square kilometers, used by people who had no fast communication technology, no printing press, no way of standardizing their script the way modern nations do. Yet the symbols are remarkably uniform across vast distances and centuries of use. This suggests a level of organized cultural communication, of shared educational systems and standardized information exchange that we would associate with sophisticated state institutions. How did they maintain that consistency? How did the same symbol mean the same thing in a city 1,000 kilometers away? We do not know. The Indus script remains one of the great unsolved mysteries of human history. But the fact that it was consistent tells us one undeniable thing. Across enormous distances and without modern tools, these people found a way to speak. We just have not learned, yet, how to listen. Here is a question worth sitting with for a moment. What is the most accurate clock ever built? If you answered an atomic clock, you are thinking in the right direction. But consider this. The most accurate clock in terms of long-term reliability. One that has never needed a battery replacement, never drifted, and never required recalibration in thousands of years, is a celestial one. Ancient civilizations understood this with a depth of appreciation we have largely lost. The Egyptian calendar, developed around 3000 before the Common Era, was built on the heliacal rising of Sirius, the brightest star in the night sky. Each year, Sirius disappeared below the horizon for approximately 70 days, and then, precisely around the time the Nile began its annual flood, it rose again just before sunrise on the eastern horizon. The Egyptians called this moment the opening of the year, and they used it to anchor their entire agricultural and ceremonial calendar with extraordinary precision. The genius of this system is its self-correcting nature. Unlike a mechanical clock that drifts over time, the heliacal rising of Sirius does not drift relative to seasonal cycles. It is a celestial clock that resets itself every year, accurate to within hours, visible to anyone with clear skies and patient eyes. Meanwhile, the ancient Sumerians of Mesopotamia developed a system for dividing time that we still use today. They divided the day into 24 hours, the hour into 60 minutes, and the minute into 60 seconds. This sexagesimal system, based on the number 60, was chosen because 60 is divisible by 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30, making it extraordinarily flexible for calculation. We inherited their system and call it ours. But it belonged always to the stars. Imagine waking up every morning knowing, without checking any device, that today was the 342nd day of the solar year, that the moon was currently entering its waning gibbous phase, and that in precisely 11 days a specific star cluster would rise at dawn, signalling the time to begin the harvest. For ancient agricultural civilizations, this was not remarkable. This was simply life. The complexity of ancient calendar systems is one of the most underappreciated achievements in the history of human thought. Consider the Mayan long count calendar, perhaps the most sophisticated pre-modern calendar ever created. The Maya tracked not just one calendar, but several simultaneously. The Solkin was a 260-day ceremonial calendar. The Harb was a 365-day solar calendar, and the long count tracked time in cycles stretching back millions of years. When these three calendars aligned, it created what the Maya called the calendar round, a period of approximately 52 years during which no 2 days were identical. Within this system, the Maya could specify any date with the precision of a modern timestamp. But here is what is truly staggering. The Maya's calculation of the solar year was 365.242 days. The modern scientific measurement is 365.24219 days. The margin of difference is approximately 17 seconds per year. 17 seconds. Over a year. Calculated without computers, without telescopes, without modern instruments. Calculated through centuries of careful observation by people sitting beneath open skies, watching the same sun rise and fall, season after season. Time, for the ancient world, was not something to be managed. It was something to be listened to. Picture yourself descending a staircase carved directly into living rock. Down you go, one level, then another, then a third. The air cools around you. The light fades to something amber and ancient. And then, as your eyes adjust, you realize you are standing in a city. A complete, functioning city built entirely underground, stretching for miles in every direction below the surface of the earth. This is Derinkuyu, in the Cappadocia region of modern Turkey, and it is one of the most extraordinary engineering achievements in human history. Discovered in 1963 when a homeowner knocked down a wall and found a passage leading into the earth, Derinkuyu is a massive underground city carved from soft volcanic rock known as tuff. It descends approximately 60 meters below the surface across at least 18 levels, though not all have been fully excavated. At its height, researchers estimate it could house approximately 20,000 people, along with their livestock, food stores, wine cellars, oil presses, water wells, schools, and places of worship. The ventilation system is perhaps the most technically impressive feature. Over 70 ventilation shafts were carved through the rock, carefully positioned to allow fresh air to circulate through all 18 levels while remaining hidden from the surface. The builders understood fluid dynamics, air pressure, and thermal convection well enough to engineer a passive ventilation system that worked without fans, motors, or any mechanical assistance. The city also featured enormous stone doors, each weighing several tons, that could be rolled into place from inside to seal entire sections against invasion. Derinkuyu is not alone. Cappadocia contains hundreds of underground cities, the largest interconnect through tunnels stretching for kilometers. Below our feet, an entire civilization breathed. There is a particular kind of silence that falls when you stand before something that should not exist, something so large, so precise, so impossibly placed, that the very fact of its presence seems to challenge everything you thought you knew. The Sacsayhuam fortress walls near Cusco, Peru, create exactly that silence. Built by the Inca civilization in the 15th century, Sacsayhuam is constructed from massive stones, some weighing over 300 tons, that have been cut, transported, and fitted together with such precision that a piece of paper cannot be inserted between them. No mortar holds these stones together. Gravity and geometric precision do, and the stones themselves are not uniform. They are irregular, multifaceted, shaped like interlocking puzzle pieces, each one uniquely cut to fit its exact position in the wall. The largest stones came from quarries located 15 to 30 kilometers away. across rugged Andean terrain, without wheels, without steel tools, without pulleys as we understand them. The Inca themselves, when asked by Spanish chroniclers how Sacsayhuam was built, referred to a mythological figure called Viracocha, essentially saying, a god built it. This is not evasion. This is the cultural memory of a civilization confronting something so far beyond ordinary experience that only the divine seemed a sufficient explanation. Modern engineers have studied Sacsayhuam extensively and reached a humbling consensus. Using the technology we believe the Inca possessed, the construction of Sacsayhuam at the scale and precision it was built is, by current estimates, practically impossible. Not difficult, practically impossible, and yet it stands, 300 tons of stone fitting together like a whisper, waiting patiently for an explanation that has not yet arrived. Let us try something together. Imagine you are inside a dark room, the air heavy with incense, the walls carved with symbols you cannot read. In the center of the room stands a stone altar, and as you approach it, without warning, a small figurine resting on the altar's surface begins to rise, slowly, silently, into the air. No strings, no machinery, just the altar and the rising figure. Now imagine being a worshipper in an ancient temple in Mesoamerica 2,000 years ago, watching this happen. What would you conclude? Researchers studying the ancient Olmec civilization have discovered something extraordinary. Among the artifacts attributed to the Olmec, some of the oldest and most enigmatic carved objects in Mesoamerican history are small hematite artifacts that appear to have been deliberately shaped and magnetized. Hematite is a naturally magnetic mineral, and the Olmec pieces show a pattern of magnetization that strongly suggests intentional orientation rather than random natural magnetization. Some of these objects appear to have been designed as compass-like tools, pointing consistently toward magnetic north with a precision that required deliberate craftsmanship. But the more provocative suggestion, raised by researchers studying temple architecture, is that the Olmec and later Mesoamerican builders may have incorporated magnetic stones into altar structures deliberately, creating zones of altered magnetic field that could levitate or move small iron ore. Magnetic objects placed on them. If true, this would mean that 2,000 years before William Gilbert wrote about magnetism in 1600, the people of Mesoamerica were not just observing magnetic phenomena, they were engineering with it. The altar was not just a place of offering, it may have been a stage for physics. What if you were to draw a line connecting every ancient sacred site you could think of? Stonehenge, the pyramids of Giza, the Nazca lines, the ancient temples of India, Machu Picchu, Easter Island, and discovered that these lines, drawn across a globe, intersected in patterns so precise they could not plausibly be coincidence? This is the premise of what researchers call the world grid theory, and while it remains controversial, the underlying geometric observations that prompted it are, quietly, remarkable. Consider the following. Stonehenge in England, the pyramids of Giza in Egypt, and the ancient city of Mohenjo-Daro in Pakistan all lie on a circle of latitude known as the 31st parallel north. These are three of the greatest architectural achievements of the ancient world, each separated by thousands of miles, built by civilizations that, as far as mainstream history tells us, had no contact with each other. Or consider this. The Great Temple of Angkor Wat in Cambodia is located at a latitude that corresponds precisely to the constellation Draco, as mapped by the ancient Egyptians, just as the three pyramids of Giza are widely noted to mirror the belt of Orion. Researcher Carl Monk spent decades documenting what he called the archaeocryptography, a system by which ancient monuments encoded their geographic position through their own dimensions and orientation. While his specific calculations remain debated, the broader pattern of ancient sites aligning with solar, lunar, and stellar phenomena across continents continues to generate serious academic discussion. Were ancient civilizations cooperating across vast distances? Were they following a shared understanding of sacred geography that we have lost? Or is the Earth itself, by its geometry and its magnetic structure, naturally suggesting where to build? Perhaps the planet was always the architect, and we were simply learning to read it. Here is a thought that might keep you awake pleasantly tonight. How did the ancient Maya know about the orbital cycles of Venus? Not approximately, not symbolically, precisely, to within a margin of error measured in seconds per year. The Dresden Codex, one of the few surviving Maya manuscripts, contains an extraordinary astronomical table. This table tracks the synodic period of Venus, which is the time it takes Venus to return to the same position in the sky as seen from Earth, across a span of approximately 104 years. The Maya calculated this period as 583.92 days. The modern scientific measurement is 583.92 days. They were, in other words, exact. The Maya achieved this not with telescopes or space probes, but with centuries of patient naked eye observation, careful record-keeping, and mathematical frameworks of breathtaking sophistication. Their number system used a concept of zero, which they developed independently of the Indian mathematical tradition, making complex astronomical calculations possible in ways that Roman numerals, for example, would have made practically impossible. And it was not just Venus. The Maya tracked the cycles of Mars, the eclipse patterns of the Sun and Moon, and the Milky Way itself, which they called the World Tree, and used as a cosmological axis for their entire understanding of time and divinity. But here is the philosophical question that makes this breathtaking rather than just impressive. Why did they need this precision? What required the Maya to calculate the orbit of Venus to within fractions of a second per year? The answer, perhaps, is that for them, the boundary between science and meaning had never been drawn. Every number told a story. Every orbit carried weight. The universe, for the Maya, was not a cold machine. It was a conversation. Take a moment and consider what it would feel like to wake up after surgery in the ancient world. You might imagine it as crude, painful, desperate, and for some times and places perhaps it was. But the archaeological evidence tells a far more nuanced and frankly astonishing story. The oldest known surgical procedure in human history is trepanation, the deliberate drilling or cutting of a hole into the human skull. Evidence of trepanation has been found on every inhabited continent, dating back over 10,000 years. And here is what is extraordinary. The majority of trepanned skulls found in archaeological digs show clear signs of healing, meaning the patient survived. Not just survived briefly, survived long enough for significant bone regrowth, indicating weeks, months, even years of life after the procedure. In a world without antibiotics, without anesthesia as we know it, without sterile conditions, ancient surgeons were successfully opening human skulls and keeping their patients alive. But it goes beyond trepanation. Ancient Indian medical texts, particularly the Sushruta Samhita, written approximately 2,500 years ago, describe over 300 surgical procedures and 120 surgical instruments. These include reconstructive rhinoplasty, which is surgery to rebuild the nose, using a technique so effective that it was adopted by European surgeons in the 18th century as the Indian method. It remains, with modifications, the basis of modern rhinoplasty. The Sushruta Samhita also describes cataract surgery, hernia repair, the removal of kidney stones, and the principles of antiseptic practice using wine, smoke, and specific plant preparations, centuries before Joseph Lister formalized germ theory. Ancient medicine was not guesswork. It was a science built on careful observation, thousands of years of practice, and a respect for the human body that at its best we are still trying to match. Picture yourself standing inside a cave, deep in the earth, where the only light comes from a small torch in your hand. The silence is absolute, and then someone begins to sing. The sound does not just fill the space. It transforms it. It bounces off the crystal walls, multiplies, harmonizes with itself, wraps around you like something alive. It feels as if the cave itself is singing back. Now imagine that the builders of ancient temples knew this feeling and decided to recreate it deliberately. Crystal quartz has been used in sacred architecture for thousands of years, and modern acoustic researchers are beginning to understand why this was not merely symbolic. Quartz crystal, by its molecular structure, has a property called piezoelectricity, meaning it generates a small electrical charge when compressed or vibrated. It also has remarkable acoustic properties, reflecting and transmitting sound in highly specific ways depending on its crystal orientation. Some of the most significant megalithic structures in the world, including many of the standing stones of the British Isles, are composed primarily of quartzite or contain large quartz deposits. Researcher Dr. Aaron Watson and others have studied the acoustic behaviour of sites like the Campster Round Cairn in Scotland and found that the chambers produce standing waves that interact with the resonant frequencies of the human voice in ways that dramatically intensify the subjective experience of sound. The practical translation of this is striking. If you placed a group of chanting people inside a quartz-rich chamber of specific dimensions, the resulting acoustic environment would not merely amplify their voices. It would create interference patterns that seem to emerge from the walls themselves, a phenomenon that could easily be described by those experiencing it as the voice of the stone. Ancient builders did not just choose their materials for beauty or availability, they chose them for resonance. They were, in the most literal sense, tuning their temples. Have you ever noticed that a sunflower's seeds spiral outward in two directions simultaneously, and that if you count those spirals, you always get consecutive numbers from the Fibonacci sequence? 21 spirals in one direction, 34 in another, or that the same sequence governs the spiral of a nautilus shell, the branching of a tree, the arrangement of petals on a rose, and the proportions of a human face. Ancient architects and artists noticed too, and they built entire civilizations around it. The golden ratio, often expressed as approximately 1.618, is a mathematical proportion found throughout the natural world that the human eye perceives as inherently beautiful and harmonious. It is not clear exactly why. Perhaps because it mirrors the proportions of the human body. Perhaps because it is simply woven into the fundamental geometry of growth and form. What is clear is that ancient builders around the world encoded it into their most significant structures, sometimes so precisely that modern mathematicians have spent years trying to understand how they did it. The Great Pyramid of Giza, for instance, embeds the golden ratio and the value of pi into its proportions in ways that have generated enormous academic debate. Whether intentional or emergent, the mathematical relationships within the pyramid are real and measurable. The Parthenon in Athens exhibits golden ratio proportions in its facade. The ancient Hindu temple at Modhera in Gujarat, India, incorporates a solar alignment alongside geometric proportions that mirror the golden ratio with remarkable accuracy. Sacred geometry was not superstition. It was the ancient perception of a mathematical language written into the universe itself, a language they read in seeds and shells and stars, and then spoke back in stone. When you understand that, the pyramids stop being monuments. They become sentences. Imagine holding in your hands a small clay bowl, cool and smooth, made thousands of years ago by someone whose name you will never know. You turn it over, run your fingers along its base, and notice a series of small marks scratched into the clay before it was fired. Symbols. Repeated. Deliberate. Not decoration. Something else. The relationship between ancient pottery and communication is one of the most quietly fascinating areas in modern archaeology. Across numerous ancient cultures, ceramic objects carry markings that appear to be far more than decorative. They carry information. In Mesopotamia, the precursors to cuneiform writing, the world's earliest known script, appear not on grand temple walls but on small clay tokens and simple pottery vessels dating back to approximately 8,000 before the Common Era. These tokens were initially used for accounting, marking the transfer of goods, quantities of grain, numbers of livestock. Over millennia, these marks became increasingly abstract and standardized until they transformed in one of the great intellectual leaps of human history into a fully formed writing system. The potter's mark, in other words, was the first sentence. But the encoding on ancient pottery goes even deeper than writing. In ancient China, pottery from the Yangshao culture, dating back approximately 7,000 years, carries symbols that some scholars believe represent an early proto-writing system predating oracle bone script by thousands of years. These symbols recur consistently across vast geographic areas, suggesting a shared system of meaning. Similarly, pottery from the Vinca culture of ancient Europe, approximately 6,000 before the Common Era, carries a set of approximately 210 recurring symbols whose purpose and meaning remain a subject of active debate. Clay, the humblest of materials, may have been the first hard drive. What would you feel if you found yourself deep in a cave in France, your torch guttering in the damp air, and the walls suddenly bloomed with images? Horses and bison and deer painted with extraordinary life and beauty. And then, woven among the animals, patterns of dots, groups of 7, groups of 6, arranged in clusters that seem somehow familiar. You are looking at the Pleiades star cluster, painted approximately 17,000 years ago. The cave paintings of Lascaux in France and Altamira in Spain have been extensively analysed and reanalysed since their discovery, and what multiple independent researchers have now concluded is remarkable. Many of the seemingly decorative dot patterns painted alongside the animals correspond with measurable accuracy to specific star constellations as they appeared in the Paleolithic night sky. This is not a metaphorical comparison. Researchers applied a principle called precession of the equinoxes, which accounts for the slow wobble of Earth's axis over thousands of years that shifts the apparent position of stars, and calculated what constellations would have been visible and prominent to people living during the period when these caves were painted. The star patterns in the paintings match. People 17,000 years ago were not just painting the world they could see around them, they were mapping the sky above them, encoding it into rock, perhaps as a calendar, perhaps as a navigational record, perhaps as a story of cosmological significance we have not yet fully decoded. And if this feels extraordinary, consider this. The oldest known star map in human history was recently identified, with some controversy, as a carved stone at Göbekli Tepe in Turkey, dating to approximately 11,000 before the Common Era. 12,000 years ago, someone looked up and made sure we would remember what they saw. Consider standing on a bridge and feeling it sway gently beneath your feet. For most of us, this is mildly unsettling. But there is a principle at work here: resonance. The tendency of a physical structure to vibrate more intensely when energy is applied at its natural frequency. If enough people walk in step across a bridge, their synchronized footfalls can create a resonant amplification that, in extreme cases, can destroy the structure entirely. Modern engineers know this. They design around it. But ancient builders, working with stone and wood and rope, also discovered resonance, and some of them appear to have used it deliberately. The most intriguing examples come from ancient suspension bridges. The Inca built a network of rope bridges across the Andes that allowed their runners and armies to cross chasms that would otherwise be completely impassable. These bridges, woven from grass fibers, were typically rebuilt every year by local communities as a communal act, and the last known Inca-era bridge at Chesuachaca in Peru is still rebuilt annually by local communities today. But what makes these bridges fascinating beyond their engineering is their acoustic behavior. When the wind passes through a well-tensioned grass rope bridge of specific dimensions, the bridge produces a low harmonic tone. Communities that maintain these bridges learned, over generations, how to tune them, adjusting tension and thickness to produce or modify that sound. In some accounts collected by anthropologists, bridge builders described specific harmonic tones as signs that a bridge was correctly tensioned and safe to cross. In other words, they were using sound as a structural diagnostic tool. Touch the bridge, listen to how it sings, and know whether it will hold. Imagine being a diver, descending through warm tropical water and having the seafloor suddenly reveal itself as a street. Then a wall. Then an entire city, silent and coral-covered, resting below the surface as if waiting for someone to return. This happens more often than you might expect. And what is found beneath the waves sometimes rewrites history in ways that are still being processed. The Yonaguni Monument, discovered by a dive instructor near the Japanese island of Yonaguni in 1986, is perhaps the most controversial of these submerged structures. Located approximately 27 meters below the surface, the monument consists of massive step terraces, flat surfaces, sharp angles, and what appear to be carved channels and passageways, all in stone. Japanese geologist Masaki Kimura spent years studying the site and concluded that it was a man-made structure, potentially a ceremonial centre or city, constructed approximately 10,000 years ago when this area was above sea level and then submerged as sea levels rose following the last ice. Age. Other geologists argue that the formation is entirely natural, the result of the tectonic and erosive processes that are common in that region. But Yonaguni is not alone. Off the coast of India, in the Gulf of Khambhat, sonar surveys in 2001 revealed what appeared to be the remains of a large urban settlement beneath approximately 40 meters of water. Artifacts recovered from the site have been dated to approximately 9,500 years ago, which would make the settlement, if confirmed, older than the oldest known civilization in recorded history. The sea does not keep secrets forever. As our technology for examining the ocean floor improves, it is becoming increasingly clear that a great deal of human history exists not in museums or textbooks, but in the quiet, dark patience of the deep water. Think about the last time you drove down a highway and took it completely for granted. The smooth surface beneath your tyres, the gentle curve engineered to drain rainwater, the precise grade that keeps your car from sliding. We tend to think of infrastructure like this as a modern achievement, something born from industrial machinery and civil engineering degrees. But what if the roads were already there? What if, thousands of years ago, someone had already solved the problem of moving people and goods across vast distances with extraordinary efficiency? The Roman road network stretched over 400,000 kilometres at its peak, covering terrain from the deserts of North Africa to the forests of Scotland. But what makes Roman roads genuinely astonishing is not their length, it is their engineering. A typical Roman road was built in layers. First came the statumen, a foundation of large flat stones. Then the rudus, a layer of crushed rubble bound with lime mortar. Then the nucleus, a finer concrete layer. And finally, the summa crusta, the surface of large fitted stones, slightly cambered, meaning curved at the centre, so that rainwater drained off to the sides rather than pooling and degrading the surface. This is precisely how modern roads are engineered. Not approximately, precisely. Roman roads were so well built that many of them still exist beneath modern European highways. In some places, modern excavations have revealed original Roman surfaces still structurally sound after 2,000 years of burial. Some Roman roads in the Middle East are still in active use. And here is the quiet profundity in all of this. The Romans did not invent road engineering. They inherited it, refined it, and scaled it. Before Rome, the Persians had the royal road. Before the Persians, the Minoans had paved pathways. Before the Minoans, still others built roads whose builders we do not yet know. The road, it seems, has always been waiting for us. Let us take a breath together and imagine a building. Not a grand palace or a towering temple, but something quieter and more powerful. a building filled from floor to ceiling with knowledge. Every scroll, every tablet, every carefully copied text representing years of observation, thought, and discovery. Imagine walking through its corridors and knowing that within these walls sat the accumulated wisdom of your entire civilization. Now imagine it burning. The Library of Alexandria is perhaps the most mourned loss in all of human intellectual history. At its height, estimates suggest it housed between 400,000 and 700,000 scrolls, covering subjects ranging from mathematics and medicine to poetry and philosophy. It was not merely a library, it was a research institution, home to some of the greatest minds of the ancient world, including Euclid, Archimedes, and Eratosthenes, who famously calculated the circumference of the Earth there with remarkable accuracy. But what is less commonly understood is that Alexandria was not unique. It was the largest of many. The ancient world was filled with libraries. The Library of Ashurbanipal in Nineveh, compiled by the Assyrian king in the 7th century before the Common Era, contained over 30,000 clay tablets covering literature, medicine, astronomy, and law. Fragments of it survive and include the oldest known written version of the Epic of Gilgamesh, one of humanity's earliest literary achievements. The library at Pergamon in modern Turkey reportedly held 200,000 volumes. The library at Caesarea in ancient Palestine was used by early Christian scholars for centuries. How much of what these libraries contained was lost? We genuinely do not know. But what we do know is this: the knowledge that survived the fires and the floods and the conquests changed the world. And what did not survive? We are still living in that silence, still trying to fill it, still not entirely sure what we are missing. Try something simple right now. Hum a low, steady note. Feel it in your chest, in your throat. Notice how the sound does not just leave your body, it moves through it. It vibrates the very structure of you. Now imagine a room designed to amplify that feeling to its absolute maximum. A room where the geometry, the material, and the dimensions were all calculated to take that hum and multiply it into something that reaches past thought and settles directly into feeling. This is not a modern recording studio. This is an ancient temple. Cymatics is the study of how sound waves create physical patterns in matter. When a surface covered with fine powder or water is vibrated at specific frequencies, the material arranges itself into extraordinarily beautiful and precise geometric patterns. Different frequencies create different patterns, reproducibly and reliably, every time. Ancient cultures appear to have known this, intuitively if not analytically, and to have built this understanding into their most sacred spaces. The Sanskrit texts of ancient India describe the concept of Nada Brahma, meaning the universe is sound, and prescribe specific tonal frequencies known as ragas for healing specific physical and emotional conditions. These prescriptions were not vague. They were precise, specifying the time of day, the emotional context, and even the season in which specific musical frequencies were most effective. Modern research has begun to take these claims seriously. Studies have found that certain frequencies in the range of 400 to 500 Hz appear to support cellular healing processes. Frequencies around 40 Hz have been linked to the kind of neural synchronization associated with deep focus and meditation. The ancient temples were not just houses of worship. They were instruments. The priests who knew how to play them were not merely spiritual guides. They were tuning the human body back to its natural frequency. Step into a garden for a moment. In your mind, rows of plants stretching toward the sun, each one carefully tended, each one the result of generations of patient cultivation. You do not think much about where those seeds came from. You simply plant them, and they grow. But what if the most important agricultural achievement in human history required no seeds at all? Ancient civilizations across the world developed sophisticated techniques for vegetative propagation, which is the process of growing new plants from cuttings, roots, bulbs, and rhizomes rather than from seeds. This may sound simple. It is anything but. The wild ancestors of many crops we eat today, including bananas, taro, and cassava, are either seeded with sterile or toxic seeds, or produce seeds so unpredictably that relying on them for agriculture would be a constant gamble. Ancient farmers in Southeast Asia, Mesoamerica, and sub-Saharan Africa independently solved this problem through deep botanical knowledge developed over thousands of years. The banana, as a staple food crop, was domesticated in Papua New Guinea approximately 8,000 years ago through vegetative propagation from wild plants. The cultivated banana we eat today is essentially a clone, propagated across millennia through cuttings rather than seeds, because the edible variety is a triploid, meaning they have 3 sets of chromosomes instead of 2, making them seedless and infertile but extraordinarily productive. Ancient farmers achieved this long before anyone understood chromosomes or genetics or the biological mechanisms involved. They did it through observation, experimentation, and accumulated generational wisdom. Today, modern agriculture faces a crisis because many of these ancient vegetatively propagated crops have low genetic diversity, making them vulnerable to disease. And the solution? Scientists are going back to the same wild plant relatives that ancient farmers first selected from, thousands of years ago. Ancient knowledge, quietly rescuing the future. Imagine arriving at a building and not being entirely sure, at first glance, whether it was built or grown. The walls curve like something living. The roof breathes. The spaces inside feel less like rooms and more like chambers in a living body, warm, responsive, somehow aware of the world outside. This is not a fantasy of modern biophilic design. This is a tradition stretching back thousands of years. Organic architecture, the practice of designing buildings that harmonize with and sometimes incorporate living biological processes, has deep roots in ancient cultures around the world. The Khasi people of Meghalaya in northeastern India have been growing living root bridges for approximately 500 years and possibly much longer. These bridges are made by carefully guiding the roots of the Ficus elastica tree, the Indian rubber tree, across rivers and ravines, weaving them through bamboo scaffolding and directing them to the opposite bank, where they take root and anchor. Over decades, the roots thicken, intertwine, and become stronger than any wooden bridge. Unlike wooden bridges, which weaken and rot with age, living root bridges become stronger every year. Some have been in continuous use for over 500 years and are estimated to be capable of supporting the weight of 50 or more people simultaneously. The Khasi did not fight against nature to build their infrastructure. They entered into a slow, patient partnership with it, one that required decades of tending before the first crossing. And then there are the cliff dwellings of the ancient Pueblo peoples in the American Southwest, built directly into and against living rock in ways that exploited the natural thermal mass of the stone for heating and cooling. The architecture did not impose on the landscape. It became part of it. When we speak of sustainable building, we are speaking, whether we know it or not, in an ancient language. Have you ever noticed that fishing communities around the world, in cultures that have never been in contact with each other, share an almost universal belief that the best fishing happens around the full moon? Or that gardeners in different traditions across Europe, Asia, and the Americas all share an intuition about when to plant and when to harvest based on lunar cycles? For a long time, this was dismissed as folklore. Then biologists started paying attention. Biodynamic agriculture, the practice of aligning planting, cultivating, and harvesting with lunar and astronomical cycles, has ancient roots across virtually every agricultural civilization. The ancient Egyptians, the Maya, the Romans, the traditional farmers of India following the Hindu Panchang calendar, and indigenous communities across the Americas all developed detailed lunar planting calendars based on centuries of careful observation. modern research has begun to validate some of the most specific claims these traditions made. Studies have found that soil moisture content fluctuates in patterns linked to lunar cycles, as the moon's gravitational influence does not just affect ocean tides, but also groundwater and soil moisture at a measurable level. Seeds planted during specific lunar phases have shown statistically significant differences in germination rates and early growth in several controlled studies, though the mechanisms are still being investigated. Maria Thun, a German researcher who spent over 50 years systematically testing biodynamic agricultural principles, published consistent findings that crops planted during certain lunar phases produced measurably higher yields than those planted during others. Her work remains controversial in mainstream agronomy, but it has never been definitively disproved. Ancient farmers did not have randomized controlled trials or statistical analysis software. What they had was time, patience, and an intimate relationship with the natural world stretching across hundreds of generations. Sometimes that is a more powerful instrument than a laboratory. Think about your keys for a moment, or your phone frame, or the knife in your kitchen. Modern metals surround us so completely that we barely notice them. We take for granted the idea that creating a specific metal alloy with specific properties is a matter of chemistry and industrial manufacturing. Now consider this. Somewhere around the 2nd century of the Common Era, a craftsman in ancient India produced a metal so perfectly engineered that a column made from it has stood outdoors in Delhi for over 1,600 years without rusting. Not significantly, not mostly, at all. The Iron Pillar of Delhi stands in the courtyard of the Quwwat-ul-Islam Mosque and has been a source of metallurgical fascination since modern scientists first analysed it in the 20th century. The pillar is approximately 7 metres tall and weighs approximately 6 metric tons. It was forged from high-purity iron over 99.7% pure, using a process that modern metallurgists struggled for decades to replicate. The secret, finally decoded in 2003 by researchers at the Indian Institute of Technology, is a thin but extraordinarily dense layer of a compound called misawite, an iron hydrogen phosphate hydrate that formed on the surface of the pillar and effectively sealed the iron against moisture. This layer formed because of the specific composition of the iron and the method by which it was forged, including the use of specific slag inclusions that modern steel production would consider impurities. The ancient Indian metallurgists did not accidentally make this alloy. They had a tradition of iron working that produced it deliberately, though they described their technique in terms of process and proportion rather than chemistry. They achieved, through craft and generations of refinement, what modern metallurgy took centuries to understand and still marvels at. Picture yourself standing at a market stall, running your fingers across a piece of cloth so vividly coloured that it almost seems to glow. Crimson deep enough to feel like something burning. Blue so pure it looks borrowed from a cloudless sky. And the trader tells you that this cloth was dyed 2,000 years ago. You find it almost impossible to believe, because colour, in your experience, fades. Everything fades, but not everything made by ancient hands. Ancient dyeing technology represents one of the most sophisticated applications of chemistry the ancient world produced, achieved entirely without laboratories, spectroscopes, or chemical equations. The Maya blue pigment, created by the Maya civilization of Mesoamerica, is perhaps the most extraordinary example. It is a vivid, intense turquoise blue that appears on Maya ceramics, murals, and ritual objects dating back over 1,000 years. And it has not faded. For decades, chemists puzzled over Maya blue. It resisted acids, alkalis, organic solvents, and the simple passage of time in ways that no single pigment should. In the 1970s, analysis revealed the secret. Maya blue was not a single compound. It was a hybrid, a combination of indigo dye molecules and palygorskite clay, where the indigo molecules were physically embedded within the nanostructure of the clay, protected from chemical attack by the lattice of the mineral itself. This is a form of nanotechnology, not metaphorically. The protection of the dye occurs at the level of individual molecules trapped within a mineral lattice, a technique that modern materials scientists are now studying and replicating. The Maya achieved this by heating specific clay with the indigo plant and copal incense at precisely controlled temperatures. They did not know they were doing nanotechnology. But that is exactly what they were doing. Colour that outlasted empires. Chemistry that outlasted understanding. Walk down any old city street in Europe and pay attention to what is beneath your feet. If you look carefully, especially where the modern asphalt has cracked or been excavated, you might glimpse something darker and older underneath. Stone fitted against stone, smooth and precise, a surface laid by hands that have been dust for 2,000 years. Ancient road building was not, as many assume, a matter of simply placing stones on the ground and hoping for the best. It was a science, one developed through hard-won empirical knowledge over many centuries. But one of the most remarkable ancient road systems in the world is neither Roman nor Greek. It belongs to the Inca of South America, and it achieves something that even the Romans, for all their engineering genius, did not fully solve: permanent mountain infrastructure. The Chapacan, or the Great Inca Road, runs for approximately 30,000 kilometers through some of the most extreme terrain on Earth, from sea-level coastal deserts to Andean peaks over 5,000 meters in altitude. Along this route, the Inca built not just roads but an entire support infrastructure: drainage channels, retaining walls, stone steps for steep gradients, and suspension bridges over gorges. What makes the Inca road system particularly astonishing is its adaptability to terrain. Rather than trying to flatten the landscape as Roman engineers tended to do, Inca engineers worked with the mountain's geometry, incorporating natural drainage, following ridgelines to minimize erosion exposure, and using local materials in ways that allowed each section to behave optimally for its specific environment. In 2023, the Chapacan was inscribed on the UNESCO World Heritage List, but the most eloquent testament to it is simpler than any certificate. After 500 years of wind, rain, earthquake and neglect, much of it still holds. It was, from the very first stone, built to last. Close your eyes and think about the last time you were truly, deeply unwell. Not just a cold, but the kind of illness that leaves you uncertain, frightened, helpless against your own body. In those moments, we reach for whatever offers relief, whatever the doctor prescribes, whatever the pharmacy provides. Now imagine living in a world where the pharmacy is a forest, and the doctor has spent 40 years learning to read it. Traditional plant-based medicine has often been dismissed by modern science as primitive guesswork. The evidence tells a very different story. Approximately 25% of all modern pharmaceutical drugs are derived from or directly based on compounds first identified in plants used by traditional medicine systems. The antimalarial drug quinine comes from the bark of the cinchona tree, used by indigenous Andean communities for centuries before European scientists isolated its active compound. Aspirin is derived from salicylic acid found in willow bark, which has been used medicinally for over 3,500 years. The ancient Egyptian Ebers papyrus, dating to approximately 1,550 before the Common Era, is one of the oldest and most comprehensive medical documents ever discovered. It contains over 700 prescriptions and remedies using plant, animal, and mineral ingredients, including treatments for conditions ranging from intestinal parasites to heart conditions, many of which have since been validated by pharmacological research. But ancient healing was not just about chemistry. It was profoundly holistic. Traditional Chinese medicine, Ayurveda, and indigenous healing traditions around the world all share a common understanding that the body, the mind, and the environment are inseparable systems, and that healing one without addressing the others is incomplete at best. Modern medicine is slowly, humbly coming to agree. The forest was always a pharmacy. We are simply, at last, learning how to read the labels. Think about the last piece of text you read. This one, perhaps. The one before it, on your phone. The one before that, on a sign or a label or a receipt. Text surrounds us with such complete constancy that we have stopped noticing it as a technology. But it is one, and it is far older than most people realize. The conventional history of printing tends to begin with Johannes Gutenberg and his movable type printing press, invented around 1440 Common Era. And Gutenberg was genuinely revolutionary. His press transformed European society within decades. But he was not first. Bi Sheng, a Chinese artisan of the Song dynasty, invented movable type printing in approximately 1040 Common Era, roughly 400 years before Gutenberg. He created individual characters from baked clay, set them in an iron frame using a mixture of pine resin, wax, and paper ash, then pressed the frame against paper. After printing, he heated the frame to melt the adhesive, removed the type, and reused it for the next page. But even Bi Sheng was not first. The Phaistos disc, discovered in Crete in 1908 and dating to approximately 1700 before the Common Era, is a fired clay disc covered on both sides with symbols that were stamped into the soft clay using pre-made seals, each individual seal producing one. Of 45 unique symbols. This is, by definition, movable type printing. 3,700 years ago. We have not yet deciphered the disc. We do not know what it says. But we know exactly how it was made. And what it tells us, silently and eloquently, is that the human desire to reproduce text efficiently is not a modern impulse. It is one of our oldest. Picture yourself in a towering ancient city, centuries before electricity was imagined. Massive stone blocks sit at the base of a monument, each one weighing several tons. Above you, workers need these blocks placed at heights that would challenge a modern crane operator. And yet, steadily, block by block, the structure rises. How? This is a question that has occupied engineers and archaeologists for decades. The mechanisms by which ancient civilizations lifted enormous weights to great heights are still not entirely agreed upon, but the evidence that has emerged paints a picture of ancient lifting technology far more sophisticated than ramps and ropes. The Romans, for instance, used a device called a polyspaston, a compound pulley system capable of mechanical advantages sufficient to allow one man to lift loads of 150 kilograms or more. Vitruvius described the polyspaston in detail in his treatise De Architectura, written approximately 25 before the Common Era. Using this system, the Romans could and did lift enormous stones to great heights with relative efficiency. But even more intriguing is the evidence from ancient Egypt. Researchers studying tool marks and construction evidence at the Giza Plateau have proposed mechanisms involving water-lubricated sledges, internal ramps with reversing spiral cores, and lever-based lifting systems using carefully positioned wooden cradles that could tilt and raise stones. Incrementally in a manner similar to a modern ratchet system. An ancient Egyptian papyrus discovered in 2013, now known as the Diary of Mira, provides direct documentary evidence of the logistics of pyramid construction, including the transport of limestone blocks by boat and the precise organisation of work gangs. It is the only surviving account written by someone involved in the actual construction. What it reveals is not magic, not mystery, but extraordinary planning, organisational intelligence, and engineering creativity applied at a scale that still stops the world in its tracks. Imagine opening a cold drink on a hot afternoon and feeling that wave of relief as the temperature difference hits you all at once. We treat refrigeration as casually as breathing. It is simply there, humming in the corner, keeping things cold, keeping things preserved. Now step back 2,500 years and ask, how did they do it? The ancient Persian engineering solution to this problem is one of the most elegant in all of history. It is called the yakchal, and it was a form of refrigeration so effective that it could produce and store ice in the middle of desert summers. The yakchal was a large structure, typically a domed mud brick building above ground, connected to a deep underground storage chamber insulated with a special mortar composed of sand, clay, egg whites, lime, goat hair, and ash, a mixture known as sarouge. This mortar was virtually waterproof and had extraordinary thermal insulating properties. Ice was produced during winter nights using shallow pools of water combined with the Kanat system, a sophisticated underground aqueduct network that brought cold water from mountain sources, and wind catchers called badgers, architectural features that funneled prevailing winds down into the structure to accelerate evaporative cooling. The ice formed during cold nights was collected and stored in the insulated underground chamber where it could persist through the blazing summer months. By summer, the yakchal provided ice for royal courts and hospitals, used for food preservation, medical cooling treatments, and the production of a cold dessert called sharbat, from which our word sherbet derives. The Persian engineers did not fight the desert. They read it. They found the cold hiding in the night air and in the mountain water, and they captured it with mud and geometry and wind. They were refrigerating long before we thought to name the concept. Hold a glass up to the light. Watch what happens. The light does not just pass through. It bends, splits, scatters into its component colours, plays across the surfaces like something alive. Glass is, in a sense, frozen light, a material so ordinary we forget it is, by the standards of human history, a miracle. The ancient world knew this, and what ancient glassmakers produced with their technology still defies easy explanation. Roman glass, produced between the 1st century before the Common Era and the 4th century of the Common Era, reached a level of technical sophistication that was not matched in Europe for over 1,000 years after the collapse of the Western Roman Empire. Roman glassblowers could produce vessels with walls less than 1 millimetre thick. They created cameo glass, layering glass of different colours, and then cutting through the outer layers to create raised relief designs of extraordinary delicacy, most famously demonstrated by the Portland vase now held in the British Museum, which dates to between 30 and 20 before the Common Era. But beyond the Romans, there exists a category of ancient glass that is genuinely inexplicable by current understanding. Libyan desert glass, found in the Eastern Sahara in large quantities, is a natural glass formed approximately 29 million years ago, likely by a meteorite or airburst event. What makes it extraordinary is its purity. It is over 98% silica, purer than almost any naturally occurring silicate glass known. And a piece of Libyan desert glass was found in the burial mask of Tutankhamun, carved into a scarab beetle. In 3322 before the Common Era, Egyptian craftsmen had recognized this extraordinary material, transported it from the desert, and placed it in the tomb of a pharaoh. They did not know its cosmic origin, but they knew, somehow, that it was unlike anything else on Earth. Think about turning on a faucet. Water comes out. Clean, safe, pressurized, reliable. We interact with this miracle dozens of times a day without a single moment of wonder. But the plumbing that delivers it is one of the great achievements of engineering history, and it is not, by any measure, a modern invention. The Indus Valley civilization, flourishing between approximately 3000 and 1500 before the Common Era, built cities with sanitation systems that would not be seen again in human history for over 3,000 years. The ancient city of Mohenjo-Daro, located in modern Pakistan, had a sophisticated urban drainage system covering the entire city. Every home had access to a bathing area with watertight floors made of carefully fitted brick, sealed with gypsum mortar. Wastewater from homes drained through covered brick channels running along the streets into larger collector sewers. These sewers were built large enough for maintenance workers to enter and clean them. They featured inspection holes, settling tanks to trap solid waste, and soakage pits. Every home in Mohenjo-Daro had drainage. This was a city of approximately 40,000 people. This level of universal urban sanitation was not achieved again in Europe until the late 19th century. But the Indus Valley achievement goes even further. Archaeological evidence suggests the presence of indoor bathing facilities and possibly indoor toilets in many homes, connected to the sewer system. The Great Bath of Mohenjo-Daro, a large public bathing structure, was constructed with such precision that it remained watertight, using a system of fired brick, gypsum mortar, and bitumen sealant. For 4,500 years, the Indus Valley cities managed water and waste at a level of civic sophistication that most of the ancient world never approached. They understood in the most practical possible terms that clean water is not a luxury, it is civilization itself. What if you came across a set of architectural drawings so precise, so detailed, so complete, that every measurement, every proportion, every structural relationship was encoded within the drawing itself with mathematical accuracy, not as a description of something to be built, but as a record of something that was built, or perhaps was meant to be built, by a mind operating at a level of architectural understanding that still raises eyebrows today. This is, in essence, what archaeologists discovered when they excavated the ancient Sumerian city of Nippur in the 1890s. Among the artifacts recovered was a clay tablet, known today as the Nippur tablet, dating to approximately 1500 before the Common Era. The tablet contains what appears to be a detailed map of the city of Nippur, accurately depicting the city walls, the major temple complex, the canals, the gates, and the surrounding landscape. Researchers comparing the tablet to subsequent archaeological excavations of Nippur have found that the tablet's proportions are remarkably accurate, representing a true scale cartographic document rather than a schematic or symbolic representation. This means that the Sumerians of the second millennium before the Common Era were producing accurate architectural maps drawn to scale. This implies a system of standardized measurement, a method of proportional reduction from real dimensions to drawn dimensions, and an understanding of spatial representation that is, by definition, the conceptual foundation of modern architectural drafting. But the Nippur tablet is not alone. Architectural drawings have been found in ancient Egypt depicting temple plans with precise dimensions noted in hieratic script alongside the drawings. In ancient India, texts known as the Vasta Shastra described architectural principles with geometric precision that guided temple construction for thousands of years. The blueprint was not invented in the industrial age, it was simply rediscovered. The idea, patient as stone, had been waiting since the age of clay. Step outside on a clear night, somewhere far enough from city lights to see the sky properly, and look up. The stars are not random, they are organized, they form patterns, and if you watch them carefully, night after night, year after year, you begin to notice that those patterns move, slowly, predictably, in cycles of breathtaking regularity. The ancient world watched. And then they built. The alignment of ancient structures with astronomical phenomena is so widespread and so precise that it constitutes one of the most significant patterns in all of archaeology. We have already spoken of Stonehenge and the pyramids, but the depth of this pattern is truly global. The temples of ancient Malta, dating to approximately 3600 before the Common Era, were aligned so that the first light of the winter solstice sunrise would penetrate directly into the inner sanctuary, illuminating the sacred space for a brief, precise window of time on the shortest day of the year. The tomb of Newgrange in Ireland, built approximately 3200 before the Common Era, features a roof box above the entrance, precisely sized and angled to allow sunlight to penetrate the inner chamber for exactly 17 minutes at dawn on the winter solstice. The sun dagger of Chaco Canyon in New Mexico, created by the ancestral Puebloans approximately 1,000 years ago, is a spiral petroglyph positioned so that daggers of light created by precisely spaced stone slabs illuminate the center of the spiral at noon on the summer solstice, and both edges of the spiral at noon on the winter solstice, with astronomical accuracy that still astonishes researchers. These were not coincidences. They required precise astronomical knowledge, repeated observation over years, and architectural execution of exceptional precision. The ancient world built its foundations on the sky, perhaps because they understood, in a way we have partly forgotten, that the sky is the only foundation that never moves. Here is a thought worth sitting with for a moment. Imagine launching an object into the sky, an object that continues to orbit the Earth silently, gathering information, marking time, telling the world below where it is and where it is going. Now imagine doing this not with rocket fuel, but with observation, mathematics, and stone. This may sound like a stretch, but consider the ancient astronomical observatories of the world, structures whose purpose was not just to watch the sky, but to interact with it in ways that blur the line between passive observation and active measurement. The Caracal, a circular observatory tower at Chichen Itza in Mexico, built by the Maya approximately 900 years ago, features window openings precisely aligned with the northernmost and southernmost positions of Venus on the horizon, as well as with specific lunar standstill positions. The orientation of the building as a whole is aligned to the setting of Venus as the evening star at its greatest elongation on specific dates in the Mayan calendar cycle. In other words, the Caracal was built to track Venus the way a modern telescope tracks a satellite, by architectural precision calibrated to a known orbital pattern. Meanwhile, the ancient Indian observatory of Jantar Mantar in Jaipur, built in the early 18th century but based on astronomical principles stretching back thousands of years, features an instrument called the Samrat Yantra, a giant sundial almost 30 meters high, capable of measuring local time to an accuracy of about 2 seconds. Other instruments at Jantar Mantar could predict solar and lunar eclipses and determine the positions of stars in real time with naked eye precision. The ancients did not send machines into the sky to measure the cosmos. They made the sky itself their instrument. And in doing so, they mapped a universe that we are still slowly learning to read. Imagine feeling a deep, aching pain somewhere in your body and having available to you a library of treatments developed and refined by practitioners across dozens of generations, each observation carefully tested against outcomes, each remedy refined to its most effective form. Not guesswork, not ritual, but empirical medicine, practiced at a level of sophistication that humbles easy assumptions about the ancient world. The ancient Greek physician Hippocrates, often called the father of medicine, established in approximately 400 before the Common Era the principle that disease had natural causes rather than supernatural ones, and that careful clinical observation was the foundation of medical practice. This was revolutionary. But Hippocrates was building on a tradition of medical knowledge that stretched back thousands of years before him. The Edwin Smith Papyrus, an ancient Egyptian medical text dating to approximately 1600 before the Common Era, is one of the oldest known surgical documents in existence. Unlike many other ancient medical texts that rely on magical incantations, the Edwin Smith Papyrus is almost entirely rational and clinical. It describes 48 case studies of traumatic injuries, each analysed with a consistent methodology, examination findings, diagnosis, prognosis, and treatment. The text distinguishes between conditions that are treatable, those that are uncertain, and those that cannot be treated, a triage framework still used in modern emergency medicine. It describes the brain, its meningeal coverings, and the cerebral spinal fluid with enough accuracy to suggest direct anatomical observation. It notes that injuries to the brain cause symptoms on the opposite side of the body, a principle known today as contralateral neurological deficit, which modern medicine uses routinely. This was written approximately 3,600 years ago. The idea that ancient people did not understand the body, that they only prayed and hoped, is not history. It is a myth we have imposed on people who deserved far better. Have you ever walked through a forest and felt, without quite being able to explain it, that the space itself was organized, that the light fell at angles that seemed considered, that the clearings opened in ways that felt intentional, that the relationship between the trees and the paths and the water somehow made sense in a way beyond accident? You may have been standing inside a form of architecture so ancient and so subtle that we barely have language for it. Across the world, from the Amazon rainforest to the forests of medieval Europe to the managed woodlands of ancient Japan, indigenous and traditional societies developed practices of landscape management so sophisticated that the environments they produced have been mistaken for centuries by outside observers as wilderness. The Amazon rainforest, long assumed to be an untouched natural wilderness, is now understood by researchers to be, in substantial part, a managed garden created by pre-Columbian indigenous societies over thousands of years. Research published in the journal Science in 2017 found that the distribution of hundreds of plant species across the Amazon is not random. Rather, edible, useful and culturally significant plants occur at dramatically higher densities near known ancient settlement sites, a pattern that could only result from deliberate cultivation and dispersal over very long periods. The Amazon as we know it, its extraordinary biodiversity, its specific composition of species, its distribution of resources, may be in large part a product of indigenous agricultural and forestry practices spanning thousands of years. In other words, the world's largest and most biodiverse forest may be, in significant measure, a garden, an invisible garden, designed without walls, without towers, without any of the markers we associate with architecture, but designed nonetheless by minds that understood, with quiet genius, that the most enduring architecture is the kind that looks like it was never built at all. Picture yourself squinting at something small and distant, straining your eyes, wishing the world would simply come into sharper focus. We all know that feeling. The way details blur at the edges, the way fine print seems to retreat from us as the years pass. And we reach, almost instinctively, for our glasses, our contact lenses, our magnifying screens, taking for granted that the correction of human vision is a modern gift. But what if someone 2,000 years ago picked up a small piece of curved crystal, held it to their eye, and saw the world sharpen in exactly the same way? The Nimrod lens, also known as the Layard lens, is a piece of polished rock crystal discovered by archaeologist Austin Henry Layard in 1850 at the ancient Assyrian city of Nimrud in what is now modern Iraq. It dates to approximately 3,000 years ago to the Assyrian Empire. The lens is oval, approximately 4.5 centimeters in its longest dimension, and it has been ground into a plano-convex shape, meaning flat on one side and curved on the other, with a focal length of approximately 11 centimeters. It is, by any technical definition, a lens. Italian professor Giovanni Pettinato proposed in 2001 that the Nimrod lens was used as a magnifying glass by Assyrian craftsmen to produce the extraordinarily fine and detailed engravings found on Assyrian artifacts, engravings so intricate that modern archaeologists initially could not understand how they had been made without optical assistance. But the Nimrod lens does not stand alone in history. The ancient Greeks wrote about burning glasses, optical devices that could concentrate sunlight to start fires. The Roman author Pliny the Elder described crystal spheres filled with water being used to concentrate light for cauterizing wounds. The ancient Egyptian hieroglyph for the Eye of Ra includes a symbol that some researchers believe may represent a lens or optical device. And then there is the extraordinary case of the ancient Romans themselves. Seneca the Younger writing in the 1st century of the Common Era, described using a glass globe filled with water to magnify written letters, noting that text which was difficult to read became clear and enlarged when viewed through the sphere. Emperor Nero, according to several historical accounts, watched gladiatorial contests through a polished emerald, possibly a corrective lens for his reported nearsightedness. Think about what this means. 2,000 years ago, a Roman emperor may have been wearing, in effect, a corrective lens. The science of optics was formally systematized by the Arab scholar Ibn al-Haytham in his extraordinary work Kitab al-Manazir, written in approximately 1015 of the Common Era, a work so comprehensive it formed the foundation for European understanding of light and vision for. Centuries afterward, spectacles appeared in Europe around 1290. But the understanding that curved transparent materials bend light in useful ways is considerably older than any of these milestones. And here is the quiet wonder at the heart of this. Every time you clean your glasses or put in your contact lenses, you are participating in a lineage of human problem-solving that stretches back at least 3,000 years. The desire to see more clearly, to bring the world into sharper focus, is not a modern aspiration. It may be one of the most enduringly human ones we possess. Think about the last time you watched a construction crew at work. The heavy machinery, the precisely mixed concrete being poured, the careful engineering of foundations designed to last decades. Modern concrete, we are told, is one of the most reliable and durable building materials ever developed, and that is true, up to a point. The uncomfortable truth that material scientists discovered in the early 21st century is that modern concrete, for all its strength when freshly poured, degrades over time. It cracks under stress, corrodes when exposed to seawater, and has a functional lifespan that engineers typically measure in decades rather than centuries. Reinforced concrete structures built in the 20th century are already showing significant deterioration. Roman concrete, by contrast, has been sitting in the Mediterranean Sea for over 2,000 years and is getting stronger. This is not a poetic exaggeration. It is a finding published in American Mineralogist in 2017 by a team of researchers led by Marie Jackson at the University of California, Berkeley. Their analysis of ancient Roman marine concrete, the material used to build harbours, piers and breakwaters throughout the Mediterranean, revealed a chemical process that modern engineers had not anticipated. Roman concrete, known as opus caementicium, was made from a mixture of volcanic ash from the region of Pozzuoli near Naples, seawater, and lime. When this mixture was poured into forms and submerged, a chemical reaction occurred over time between the seawater and the volcanic ash, producing crystals of a mineral called tobermorite within the concrete matrix. These crystals grew slowly, filling in microscopic cracks and binding the material more tightly together with each passing decade. In other words, Roman concrete self heals in seawater. It becomes stronger over centuries, not weaker. The Roman engineer Vitruvius described the properties of this volcanic ash, which the Romans called pozzolana, in his treatise De Architectura, written around 25 before the Common Era. He noted that this ash, when mixed with lime and seawater, produced a material of extraordinary hardness even when submerged. He was not explaining a chemical reaction. He was passing on empirical knowledge accumulated through generations of observation. The Romans learned that specific volcanic ash, combined with lime and seawater in specific proportions, produced a concrete of remarkable durability. They applied this knowledge to build the Pantheon, whose unreinforced concrete dome, spanning 3.3 metres, has stood without significant structural repair for nearly 2,000 years and remains the largest unreinforced concrete dome in the world. The harbour of Caesarea Maritima in ancient Israel, built by Herod the Great approximately 25 before the Common Era using Roman pozzolanic concrete techniques, still shows the outline of its submerged structures today, massive blocks holding their form after 2,000 years beneath the sea. Modern researchers are now developing a new generation of concrete formulations inspired directly by Roman practice, using volcanic ash additives to produce more durable, more sustainable concrete with a dramatically reduced carbon footprint. 2,000 years of engineering wisdom lying quietly in the harbours of the Mediterranean, waiting for someone to stop dismissing the past and start listening to it. Imagine setting an alarm, not for tomorrow morning, but for 1,000 years from now. Not a digital clock, not a mechanical spring, but a message encoded in stone and shadow, and the patient turning of the earth itself, designed to deliver its information to whoever is standing in the right place at exactly the right moment, a millennium later. This is not science fiction. This is what the builders of some of the world's most enduring ancient monuments effectively accomplished, and the mechanism they used was one of the oldest and most reliable clocks in existence: the movement of light. The winter solstice, the shortest day of the year in the Northern Hemisphere, occurs each year around the 21st of December. On this day, the sun rises at its southernmost point on the eastern horizon, travels its lowest arc across the sky, and sets at its southernmost point in the west. This position is predictable, fixed within seconds, year after year, century after century. Ancient builders use this consistency as the escapement of their stone clock. The Passage Tomb of Newgrange in County Meath, Ireland, was constructed approximately 3,200 before the Common Era, making it older than both Stonehenge and the Great Pyramid of Giza. Its builders shaped a long, narrow inner chamber aligned precisely with the winter solstice sunrise. Above the entrance, they built a small rectangular opening known as a roof box, positioned at a specific angle to admit the first light of dawn on the solstice. Each year, on the winter solstice, for approximately 17 minutes beginning at sunrise, a narrow beam of light enters through the roof box and travels the full length of the 19-metre passage to illuminate the inner chamber. The effect is described by everyone who has witnessed it as almost incomprehensibly moving. Out of total darkness, a golden light grows and fills the chamber with extraordinary precision, and then slowly retreats as the sun continues its arc. This has been happening, without interruption, for 5,200 years. The builders of Newgrange achieved this alignment without modern surveying instruments, without computers, without a single device we would recognise as a precision tool. They achieved it through years of patient observation, careful planning, and construction of extraordinary precision. The roof box is oriented to an accuracy of less than 1 degree from the true solstice sunrise azimuth, and here is what makes this a sleeping clock rather than simply an architectural curiosity. The alignment does not just mark the solstice. In the context of the ancient communities that used Newgrange, the winter solstice marked the death of the old year and the beginning of the sun's return. The light entering the chamber was understood as a renewal, a cosmic reassurance that the darkness would end and the warmth would return. The monument was, in the most literal sense, a machine for delivering hope on the darkest day of the year, and it delivered that message reliably, year after year, for over 5,000 years, sleeping patiently in the Irish countryside and waking, precisely and faithfully, every December. No battery required, no maintenance scheduled, just the earth turning, and stone waiting, and light doing what it has always done. Close your eyes and picture yourself standing at the edge of the Pacific Ocean, somewhere on a small island. Behind you, the island is everything you have ever known, its trees, its reefs, its people. Before you, the ocean extends to the horizon in every direction, featureless, vast, terrifying in its completeness. There is nothing out there that you can see. No land, no landmark, no map. Now step into a canoe and sail toward a destination 3,000 kilometers away that you have never seen. This is what the ancient Polynesian navigators did, routinely, across the largest ocean on Earth, using a system of navigation so sophisticated and so entirely different from anything in the Western tradition that European explorers, upon encountering it in the 18th century, refused to believe it was real. The Polynesian expansion across the Pacific, which began approximately 3,500 years ago and reached its most distant points, Hawaii to the north, New Zealand to the southwest, and Easter Island to the east, represents one of the greatest feats of human exploration ever. Accomplished. The navigators who achieved this had no magnetic compass, no sextant, no written charts, no GPS, no instruments of any kind recognizable to the Western navigational tradition. What they had was a system of knowledge so comprehensive and so refined that it transformed the entire ocean into a readable landscape. Polynesian navigators read the stars with a precision that European astronomers admired. They memorized the rising and setting points of hundreds of stars and used these as directional markers, understanding that each star rises in roughly the same place on the horizon every night. By keeping a mental star compass with the rising and setting points of specific stars mapped around the full 360 degrees of the horizon, they could hold a course across open ocean through the night with extraordinary accuracy. But star navigation alone does not explain the full achievement. During the day and in cloudy conditions, Polynesian navigators used a set of additional information sources that are, in their own way, even more impressive. They read ocean swells. The deep Pacific is crossed by long, low swells generated by distant storms and wind systems, and these swells maintain their direction with remarkable consistency over vast distances, unaffected by local winds or surface conditions. Polynesian navigators learned to feel the movement of these swells through the hull of their canoe and through their bodies, particularly their lower torsos, and could identify the direction of up to 5 or 6 distinct swell systems simultaneously, using this information to maintain course even. When completely blind to the sky, they read clouds. Specific cloud formations tend to form over islands even when the land is below the horizon, because the thermal and moisture properties of land create distinctive atmospheric effects. A skilled navigator could detect the presence of a distant island by reading the clouds above the horizon. They read the behavior of birds, whose flight patterns and species indicated proximity to land. They read the temperature and color of the water, which changed near island chains and shallow reefs. They read phosphorescent plankton at night, which, disturbed by the swells near islands, could indicate proximity to land masses. And they carried all of this knowledge not in books or charts, but in their bodies, their songs, their oral traditions, and their dreams. Navigation was not a skill in Polynesian culture. It was a way of being in the world, a relationship with the ocean so intimate and so complete that the water was never empty. It was always full of information for those who knew how to read it. The last master practitioners of this traditional navigation, known in the Marshall Islands as rebelib and in Hawaii as wayfinding, were nearly gone by the mid-20th century as Western navigation tools replaced traditional knowledge. But in 1973, a project called the Polynesian Voyaging Society was founded, and a traditional double-hulled voyaging canoe named Hokulea was built. In 1976, navigator Mau Piailug, one of the last living traditional navigators, sailed Hokulea from Hawaii to Tahiti using only traditional methods, with no instruments. The ocean had not changed. The knowledge had simply been waiting for someone willing to carry it forward. Have you ever caught a scent unexpectedly? Something in the air of a garden or a market or an old book, and felt it carry you somewhere completely without your permission? Not just a memory, but an entire feeling, a whole emotional landscape arriving fully formed before you even had time to think. Smell is the most direct of our senses, the one that bypasses analysis and goes straight to feeling. We know this intuitively. And, it turns out, so did the ancient world. The history of perfumery is one of the oldest and least told stories in human civilization. It stretches back at least 4,000 years and encompasses some of the most sophisticated applications of chemistry, botany, trade economics, and cultural psychology that the ancient world produced. The oldest known perfume factory in the world was discovered in Cyprus in 2003 at a site called Pyrgos. The facility dates to approximately 4,000 years ago and contained distillation equipment, mixing bowls, funnels, and residue analysis revealed the presence of at least 14 aromatic substances, including anise, pine, coriander, bergamot, almond, and parsley. These were not simple flower waters. They were complex, multi-ingredient formulations produced at an industrial scale. But the ancient perfume tradition that most deeply deserves our attention belongs to Egypt. The ancient Egyptians did not simply enjoy fragrance for pleasure, though they certainly did. They understood it as a technology. Their word for perfume was kaifi, and their most sacred formulation by that name was a complex blend of up to 16 ingredients, including honey, wine, raisins, myrrh, frankincense, sweet flag, juniper, and various aromatic resins that took days to prepare following precise procedural. Instructions recorded in temple inscriptions at Edfu and Philae. Kaifi was burned as an incense offering to the gods, but it was also used medicinally, prescribed in the Ebers Papyrus for conditions including asthma, anxiety, and sleep disorders. Modern analysis of Kaifi's documented ingredients reveals that several of them contain compounds with genuine pharmacological activity. Myrrh has documented antimicrobial and anti-inflammatory properties. Frankincense contains boswellic acids, now being studied for their effects on brain function and anxiety. Several of the aromatic resins in Kaifi contain compounds that modern pharmacology classifies as sedatives or anxiolytics. The ancient Egyptians were not burning sacred smoke and hoping for divine intervention. They were administering a precisely formulated multi-ingredient therapeutic inhalant through a delivery mechanism, combustion and diffusion through air that ensured wide distribution and absorption through the respiratory system. And beyond Egypt, the ancient spice and aromatic trade routes that connected India, Arabia, East Africa, and the Mediterranean world were among the most economically significant trade networks in all of human history, precisely because the demand for aromatic substances was so universal and so intense. The value of frankincense at various points in ancient history exceeded that of gold by weight. Nard, a perfume derived from the spikenard plant of the Himalayas, is mentioned in the Song of Solomon and appears in the New Testament as the substance Mary Magdalene poured over Jesus' feet. A single jar of it was worth approximately 300 denarii, roughly a year's wages for an average labourer in the 1st century of the Common Era. These were not indulgences of the wealthy few. Fragrance was considered, across virtually every ancient civilization, as essential as food. It was medicine, it was prayer, it was identity, it was diplomacy. Specific fragrances were associated with specific deities, specific rituals, specific moments of human transition, birth, marriage, illness, death. The ancient world understood with an intuitive certainty that modern neuroscience is only now formally articulating. That smell is the most direct pathway to the deepest parts of the human mind. And they spent thousands of years learning how to speak that language with extraordinary precision. Every time a candle fills a room with warmth and fragrance, every time you catch the smell of something that returns you unexpectedly to a particular moment in your life, you are experiencing the same truth that an Egyptian priest understood 4,000 years ago while grinding resins in the light of a temple torch. Scent is not decoration. It is a key, and the ancient world knew exactly which doors it could open. Picture yourself lying on a stone table, the air cool and still around you, the flicker of oil lamps casting warm shadows on the walls. A figure stands beside you, calm and unhurried, grinding something in a small bowl. Herbs, roots, resins. The smell rises slowly, something earthy and sweet and faintly bitter all at once. They bring the bowl close. you breathe deeply, and then softly the world grows quiet. No machines, no sterile packaging, no syringe, just plants and knowledge and hands that have done this many times before. This was surgery in the ancient world, and it was far more humane than most people imagine. The idea that ancient patients simply endured procedures while fully conscious, gripping leather straps and hoping for the best, is one of the most persistent and least accurate assumptions about the past. The archaeological and textual evidence tells a very different story. Ancient Egyptian medical papyri, including the Ebers papyrus dating to approximately 1550 before the Common Era, document the use of opium derived from the poppy plant as a sedative and pain-relieving agent. The poppy was cultivated in Egypt from at least the New Kingdom period, and opium's active compounds, morphine and codeine, are among the most potent, naturally occurring analgesics known to pharmacology, ancient or modern. In ancient China, the physician Hua Tuo, practicing in the 2nd century of the Common Era, is recorded in historical texts as using a compound called mephisin, dissolved in wine, to render patients completely unconscious during surgical procedures, including abdominal operations. The exact composition of mephisin is debated, but researchers believe it contained cannabis, datura, aconitine, and possibly other alkaloid-containing plants, a combination that modern pharmacologists confirm would produce profound sedation and analgesia. The ancient Greeks and Romans used a preparation called the sleeping sponge, a sea sponge soaked in a solution of opium, mandrake, henbane, and mulberry juice, then dried. Before surgery, the sponge was rehydrated and held under the patient's nose. The active compounds, absorbed through the mucous membranes of the nose and mouth, induced sedation within minutes. To revive the patient, a second sponge soaked in vinegar was applied, the acidity helping to counteract the alkaloids and restore consciousness. This is not folk magic. This is applied pharmacology, using plants whose active mechanisms are fully understood by modern chemistry and whose effectiveness has been repeatedly validated. What is perhaps most remarkable is not that these substances worked, but that ancient practitioners knew precisely which plants to combine, in which proportions, and in which preparation methods to produce reliable, controllable anesthesia. This knowledge was not stumbled upon by accident. It was the product of generations of careful observation, refinement, and transmission, a body of pharmaceutical knowledge built over centuries and passed through medical traditions with the same seriousness we attach to modern clinical protocols. The aha moment here arrives quietly the next time you receive anesthesia before a procedure and drift into that soft, painless darkness. You are experiencing something ancient practitioners worked for generations to provide for their own patients. The chemistry has been isolated, purified, and precisely dosed. But the fundamental compassion behind it, the determination to ensure that a person in need of healing does not have to suffer unnecessarily, is as old as medicine itself. Pain was never something ancient healers simply accepted. They fought it with every tool the natural world offered them. And the natural world, it turns out, offered quite a lot.